Today we started with a lot of words on the wiki page that we put in our journal, and we left a space to give an example. Starting with the Premack principle, this is when you use a behavior instead of a stimulus to reinforce or strengthen or encourage a behavior. David Premack out of the University of Pennsylvania came up with this term. In a great example in our rat project is when we rewarded the rats instead of with like a potato chip or a pellet, but we gave an activity that they like. For example, running around in their cage or running on a wheel. Now you don't want to just say a cage, giving your rat a cage, because that's a stimulus, but actually letting them run around in it. Some of you, I noticed, your rat would actually run up and down, and actually enjoy being in the cage, not just the cage itself. So Premack principle is using an activity or behavior instead of just a stimulus to reinforce or strengthen a behavior. So we wrote these words. If you want, you can kind of pause this video if you have your journal, and you can put them in your own journal, or you can, when you come back to school, make sure to put them in. But these words are on the wiki. You'll want to add your own example. The first two words that we started with are avoidance and escape. Avoidance is when you do a behavior to prevent an annoying stimulus. Escape is when you do a behavior to stop an annoying stimulus. I'm going to give you two human examples, and then why don't you pause this video and kind of answer some questions in the form if you want, or you can go back and do that at the end of the video. But avoidance is when you do a behavior to prevent an annoying stimulus. So for example, I do a behavior like stopping at a stop sign so that I don't get in a car accident. Notice the car accident hasn't happened yet, but I'm doing the behavior, slowing down at the stop sign, to prevent or, make sure that the horrible thing or the aversive stimulus doesn't occur. In escape, I do a behavior to stop an annoying stimulus that's already happening. So I put my seatbelt on in the car because the annoying stimulus, ding, 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 is happening. And when I put my seatbelt on, it makes it stop. Okay, so you can answer some questions on the form that relate to avoidance and escape. There are 4 questions, and then come back to the video if you want. It might be an easier way to go about the lesson. All right, the next part of the lesson, we just talk about in what order do behaviorists work. And in behaviorism, remember, we are trying to reinforce, right? So we might have an antecedent stimulus, maybe holding a potato chip at first, but then after the behavior, then we have a consequence, which, as we saw in yesterday's quiz, could be positive, something we add, or negative, something we take away. Then, for classical conditioning, the best order is the neutral stimulus, right, the clicker, and then the food, or UCS, the unconditioned stimulus, the thing you're born to react to. This is also called delayed conditioning. Remember all those words we went over in the beginning, like trace, where there was a space, and simultaneous and backward? You need to know those for the test. All right. So why am I bringing all this up again? Because we're going to look at now the behaviorists and the critics, the people who think that there's more to learning than just rewards. So at the start of behaviorism, we could group Ivan Pavlov, the man who made the dog salivate at the bell. This is Pavlov here. We could definitely group that with behaviorism, the first aspects of learning. And we can also put the man who classically conditioned a baby to be fearful of rats, John Watson, the father of behaviorism. Remember, he's the guy who said, give me a baby and I'll turn it into a murderer or a lawyer. I kind of just picture him saying that as he wrings his hands, like in this photo. Then another behaviorist who's not necessarily the father of behaviorism, definitely a proponent of behaviorism, the idea that environmental context and behaviors are shaped or changed by the rewards and consequences around them. That was B.F. Skinner. And he is our best friend. I like to call him our BF, but remember, he's the one who made the operant chamber and all the words like schedules of reinforcement. He also made the words like positive and negative reinforcement. He's basically the crux of our whole learning project with the rats. Now, these guys strongly believe that, right, stimuli and consequences made people learn. But there were some other people who thought it isn't just about rewards and punishments, but that there's more to learning. One man was Edward Tolman, who did studies in the 1930s and the mid-1900s. He actually thought the brain was involved in learning, and you didn't actually need to have stimuli or rewards and punishments, that your brain naturally tried to learn things. 2 ways he proved this was cognitive maps, which I'll talk about here shortly, and latent learning. So we'll go into what Edward Tolman's studies did. And I'm going to try to use Draw Island. Hopefully it cooperates with me. I'm going to import a picture of 2 mazes. And if I can't, try it one more time. Okay, here it goes. It's loading the image. So what Edward Tolman did was that he had rats run through a maze and go from A to B. I'm just going to blow this up for you a little bit. So they just kept running the maze, and there was a little bit of food at B. Now there was a little bit of a small wall or removable barrier in this part here. Well, Edward Tolman thought that if the rat truly had this maze in his mind, this rat knew that turning right gave him the reward, but he also knew that to the left there were no reward. He also knew that there was something in front of him. Maybe he hadn't explored it, but he knew that there were 4 arms to this maze, as much as his brain could tell. Now, what's interesting is when Edward Tolman took out the barrier and started the rat at letter C, the rat did something pretty fascinating. Now, think about it. If the rat truly knows this maze in his mind, which way would he turn for the food? Now, remember, he's used to turning right. But actually, when the rat started at C, he turned left to B. So by turning in the opposite direction, it showed that the rat knew the maze in its mind. And that's really what a cognitive map is. A cognitive map is a mental representation of a layout in your mind. So like, for example, you may know how to get around the school even with your eyes closed, or even how to get through the classroom. Latent learning is similarly related in that you're learning what you have done is hidden until there's an incentive to do so. So Tolman actually had other mazes, not just these T mazes, but he also had these radial arm mazes where there were multiple arms. And he did similar experiments where he would put the food in one of the arms and then try to start the rat in another arm. So for example, let's say the food is here, and he always started the rat at S where it starts, and the rat got used to going into this arm. Even going from other arms, the rat knew to do this. Now, in latent learning, Tolman just let rats roam through a maze. And they were able, even without any reinforcements or punishments, to go from the beginning to end. After 7 days of just roaming, he put a reward at the end, and the rats knew the beginning from the end. This is latent learning, where you actually know the maze. The rats probably know the maze. We now have studies of brain imaging that shows they dream about the maze. But until they have a reason to show you that they know it, it may not be visible. And so, remember the behaviorists. Let's go back to those behaviorists. They were all about observable behaviors. They wanted to study observable behaviors. But the cognitive psychologist was saying sometimes things could actually be hidden. There could be learning in the brain that you might not visibly see, maybe unless there's an incentive to do so, like some food at the end of the maze. All right, so Tolman's rats, even the ones that just roamed the maze, they actually went faster than rats who had been rewarded and punished for learning the maze in a certain amount of days. The next critic of behaviorism is a guy named Albert Bandura. Now, both B.F. Skinner and Albert Bandura are people's secret names. And Albert Bandura is a pretty well-known psychologist. He just received a medal while President Obama was the president. He got a Medal of Science for what his research did in psychology. He was a professor at Stanford. And we're going to look at his experiment. It's called the Bobo doll experiment. And he also talks about a term called modeling. Now, Albert Bandura believed in what's called social or observational learning. That is, you can learn by watching. So let's look at his study. We'll use this video. And I'll first let you get just to hear Albert Bandura a little bit. This is Stanford in Palo Alto, California.
Styles of behavior through modeling. Children watched a filmed adult perform novel aggressive acts toward a inflated doll, and the physical aggression was accompanied by novel hostile remarks. We later measured how much of this
You might say, wow, what is this? What's the big deal about this guy's experiment? He showed that we learn not just through rewards, punishments, and chips and cookies. We actually learn by watching. So here's what he did. He had an adult beat up a Bobo doll. If you don't know what a Bobo doll is, it's kind of like those blow-up balloons where you punch it and it pops back up. Now, the adult models could have been male or female. You're going to see a female one. And they would beat up the doll. They would use different things. They'd even say things like, "Take that, you stupid doll," and they would say comments. Some children watched the adult model and then went in a playroom. Other children didn't have a model and they just went in a playroom to play with toys. So that's what you're about to see is the Bobo doll experiment.
Model pummeled the doll with the mallet, flung it in the air, kicked it repeatedly, threw it down and beat it.
Take that, you Bobo doll. So then when the kids had watched the adult, they went into the playroom. Now, you hit these Bobo dolls, so that's normal. But what was interesting about the kids who had watched the adult model is they did do something different.
It was once widely believed that seeing others vent aggression would drain the viewer's aggressive drive. As you can see, exposure to aggressive modeling is hardly cathartic.
So they not only mimicked or copied what they saw the adult person do.
Exposure to aggressive modeling increased attraction to guns, even though it was never modeled. Guns had less appeal to children who had no exposure to the aggressive modeling.
So the
Children
kids who
also
watched an
picked up
adult,
powerful hostile language.
they invented new ways to beat up the Bobo doll. As you see, and you heard Bandura say, they were more likely to pick up the gun and be more attracted to the toy gun in the playroom. And interesting, they would invent new ways to beat up on the Bobo doll. The kids who did not watch an adult model beat up the Bobo doll did not pick up new toys to beat the Bobo doll with. Now, there's also a little girl who does the same thing and watched an adult model. Basically, before Bandura did this experiment in the late 60s, people thought that if you watch someone be aggressive, it would drain you of their aggression. Like it would just be a cathartic thing. It would release all the feelings of anger in you if you watch somebody else be aggressive. But Bandura's experiment proves if you watch aggression, you'll actually copy it. It can make you more aggressive. So here the boy has the gun in one hand and the mallet in another. Here's the little girl, also watched an adult model beat up the doll. Now I think she's taken a mallet to her dolls. So that's Bandura's Bobo doll experiment. And again, what's important about this is you don't just need rewards to learn. You can learn by watching. Now, the key thing about modeling is you must copy. It's not just that you watch someone do something. And when you put examples of these in your journal, please don't say that your rat watched another rat do something and then learn, because that's probably not likely. But you definitely watched videos during the project to show a rat how to play rat basketball, or you maybe even watched me as the teacher show you how to do something and you copied it. That's the key thing about modeling. It's not just watching, but actually, repeating the same behavior that you see. All right, hopefully this helps you and there's some questions to answer. That's about as far as we got. Thanks, everybody.